Space is not your friend. It's beautiful, mysterious, and utterly lethal. Tonight we're diving into the dark truths about the cosmos that most shows gloss over or turn into pretty wallpaper. Let's start with something simple. Take a deep breath. Feel your lungs fill with air. Now imagine stepping outside a spaceship with no suit. The vacuum of space. There is no air, no pressure, no sound. You wouldn't explode like in the movies, but your blood would start to boil, your lungs would collapse, and you'd pass out in seconds. Space isn't just empty, it's actively hostile to every part of your body. But maybe, you think, we'll be safe inside our ships and stations. Not exactly. Invisible bullets are flying through space all the time. Tiny grains of dust, frozen bits of rock, micrometeoroids traveling faster than bullets on Earth. If even a small one hits a spacecraft, it can punch straight through metal. Astronauts rely on layers of shielding and a lot of luck, because in space, even dust can kill. Now zoom out from the tiny to the huge. Stars look calm from here, little twinkling lights in the sky. But inside, they are nuclear furnaces. Constant thermonuclear explosions. Our own sun is stable right now, but it still spits out massive solar flares. Bursts of radiation and charged particles that can damage satellites, knock out power grids, and bathe astronauts in dangerous radiation. And our sun is gentle compared to some. Across the galaxy, there are monsters called magnetars. These are ultra-magnetized neutron stars, the collapsed cores of dead massive stars. A neutron star packs more mass than our sun into a ball the size of a city. A teaspoon of neutron star material would weigh more than a mountain. Magnetars take that horror and add magnetic fields trillions of times stronger than Earth. If you got anywhere near one, its magnetic field could literally tear atoms apart and scramble the chemistry in your body. And then there are gamma-ray bursts. Imagine a star many times bigger than our sun, dying in a spectacular collapse. In a fraction of a second, it can release more energy than our sun will emit in its entire 10 billion-year lifetime. Focused into narrow beams of intense radiation, a gamma-ray burst pointed at Earth from just the right distance could strip away our ozone layer and fry the surface with UV radiation. No fireball, no warning, just a sudden global extinction event written in invisible light. Feel small yet? Good, because the universe is just getting started. Let's talk about black holes. They're the poster child for cosmic horror. Regions of space where gravity is so strong that not even light can escape. Cross the boundary, called the event horizon, and you are done. No signal, no message, no escape. Time itself stretches and warps near a black hole. From far away, you'd appear to slow down, freeze, and fade. From your point of view, you'd plunge forward. Spaghettified. That's the actual term astrophysicists use. Your body stretched into a long, thin strand as gravity pulls harder on your feet than your head. At the centers of most galaxies, including ours, sit supermassive black holes. Millions or even billions of times more massive than our sun. They feed on gas, dust, stars, even other black holes. As matter spirals in, it heats up and glows, sometimes brighter than an entire galaxy. We call these active monsters quasars.
For all their power, they are silent assassins on the grandest scale. And yet, black holes might not even be the strangest things out there. Because most of the universe is made of stuff we can't see, can't touch, and don't understand. Look around you. Everything you can see. Planets, stars, clouds of gas. You, me, your phone, your room. All of that is made from what we call normal matter. Protons, neutrons, electrons. The familiar building blocks of atoms. But here's the dark truth. Normal matter is only about 5% of the universe. 5%. About 27% is something we call dark matter. We can't see it directly. It doesn't glow, reflect, or absorb light the way normal matter does. We only know it's there because of its gravity. Galaxies spin too fast to hold together with just the visible stars. They would fly apart if something unseen weren't holding them in place. That invisible glue is dark matter. It may be made of unknown particles that barely interact with anything. Right now, experiments deep underground and in space are trying to detect even a single dark matter particle. So far, nothing confirmed. The rest, nearly 68% of the universe, is even stranger. We call it dark energy. It's not like energy in your phone or in a battery. It's a mysterious property of space. In the late 20th century, astronomers discovered that the expansion of the universe is not slowing down. It's speeding up. Something is pushing galaxies away from each other faster and faster over time. That cosmic repulsive force is what we label dark energy. We have almost no idea what it really is. Think about that. 95% of the universe is invisible, untouchable mystery. Our entire civilization, our science, our history, all sit inside a tiny 5% sliver of reality. Now let's drop another unsettling fact. The universe has no obligation to be understandable to human brains. We evolved on a small rocky planet, dodging predators, finding food, dealing with weather. Our senses and instincts are tuned for survival, not for grasping quantum fields, curved space-time, or extra dimensions. Yet those things might be the real foundation of everything. On the smallest scales, reality behaves like a glitchy video game. Quantum mechanics tells us that particles can be in multiple states at once. They don't have a definite position or speed until we measure them. At a deep level, nature is ruled by probabilities, not certainties. The universe literally refuses to tell us exactly what's going on, even in principle. On the largest scales, space-time itself is curved and stretched by matter and energy. Massive objects like stars and galaxies don't just sit in space, they bend it. What we feel as gravity is really objects following the curves in this warped fabric. Light itself can be bent around galaxy clusters, creating cosmic mirages and distorted arcs in the sky. And all of this might be just one universe.
Some theories in physics suggest that our universe could be part of a multiverse.
Countless other universes, each with different physical laws, different particles, different constants. In many of them, stars might never form, or atoms might not exist. Some might expand and die in a fraction of a second. Others might last forever. We don't know if the multiverse is real, but the fact that it's a serious scientific idea tells you how far from home our curiosity has taken us. Now, let's confront a question that haunts a lot of people. Are we alone? When you look at how enormous the universe is, it seems almost impossible that we are the only intelligent species. There are hundreds of billions of stars in our galaxy alone, and possibly trillions of galaxies in the observable universe. The odds feel like they should be in favor of life, maybe even advanced civilizations. But here's the dark side. We haven't found anyone. No clear signals, no megastructures around stars, no alien craft cruising past our telescopes. This silence is sometimes called the Great Filter. Maybe intelligent life is rare. Maybe it tends to wipe itself out. Maybe space is full of dead civilizations that reached a certain point and then vanished, leaving only silent planets and cold ruins. Or maybe we're just early, or too primitive to notice what's really out there. Either way, the universe is not obligated to comfort us with neighbors. And finally, we have to ask, how does this all end? Not just your life, not just human civilization, everything. Right now, the best evidence suggests that the universe will keep expanding. Galaxies will drift farther and farther apart. New stars will form for a while. But eventually, the fuel runs out. Stars die. Black holes slowly evaporate through a process called Hawking radiation, leaking energy over unimaginable time spans. Trillions upon trillions of years into the future, the universe could become a cold, dark, thin fog of particles. No stars, no light, just the quiet spreading out of what used to be everything. That's one possible ending. A heat death, not with a bang, but with an endless fading sigh. So yes, the universe is beautiful. The night sky is full of wonders. But behind the beauty is a reality that is harsh, indifferent, and overwhelmingly strange. Here's the twist, though. In the middle of all that darkness, you exist. A tiny pocket of order in a vast ocean of chaos. A cluster of atoms that can think about its own existence, that can look up, ask questions, and slowly peel back the layers of cosmic mystery. Maybe that's the brightest secret of all. The universe is terrifying, but somehow, against all odds, it gave rise to you, staring back at it, daring to understand the dark.